Welcome to Curtita's Math. Today we are going to be doing the Pythagorean Theorem. So the Pythagorean Theorem is something that you can use when you have a right angle triangle in order to find a missing side. So the first thing we're going to do here is put in our handy formula. The formula that we're working with is a squared plus b squared equals c squared, where a and b are the sides or the legs of the right angle triangle, and C is the longest side of the right angle triangle. It's the hypotenuse. So this is the hypotenuse, the longest side, and that's the most important label since there is only one side in the triangle that is the longest. A and B are the other two smaller sides, and we often call them the legs. So legs, and they're the smaller sides. And A and B are interchangeable for this reason. So we're going to look at this example here where we have the two legs of the triangle, and we're looking to find the missing side. I should have put a X here. So we're trying to find this X, and we have these two other sides. So one thing that you can use to find your hypotenuse, other than it being the longest side, sometimes if your triangle is drawn kind of really skinny, oops, thought I was drawing an arrow. Now it thinks I'm drawing a rectangle. So if it's really skinny like this, sometimes it's hard to tell which side is the longer side. So something that you can look for is the right angle. So this right angle over here is what tells you which side is the hypotenuse. It's the side that the right angle is looking at. So this tells us that this side over here, that's the hypotenuse, which means that's what must be labeled as C. The other two sides, it doesn't matter if you label them as A or B. It makes no difference. So we'll label this just A and B. So labeling is your first main step in the Pythagorean theorem. So let's move all of this, put that up here. So step one is we label the sides. Now step two is we plug in to the formula. Actually get some smaller lines here. So we're going to plug in a squared plus b squared equals c squared. So in this case, our a is 4. We're going to replace a by 4. B is 3. We'll replace b by 3. And c is what we don't know. And now all we need to do is solve for c. So 4 squared, 16, 3 squared is 9, c squared, 16 plus 9 is 25 equals c squared. So now we have 25 is c squared. 25 is not the length of this side. So we don't want c squared. We just want c. And the way that you undo a square is by square rooting. So we have to square root on both sides to get rid of that little square symbol above the c. So now we're left with 5 equals c. That's the length of our missing side. And looking at our triangle, that makes a lot of sense. 3, 4, and 5. Okay, so now we're going to do the same thing over here. I should have put in the right angle here. So our first step is always labeling. So step 1, label. So here we locate our right angle and then see which side is the right angle looking over at. That's going to be our C. So 10 is C, the other two can be A or B. So A, B. Now we write out our formula and we plug in. A squared plus B squared equals C squared. So in this case, A is what we don't know. You can leave it as A squared. You can replace the A by X. It's really up to you. It doesn't really matter. As long as you're solving for a variable here. Okay, B is 6 plus B, not B, plus 6 squared. And C is 10. 10 squared. Now solve what we know. We have A squared plus 6 squared is 36. 10 squared is 100. And now our goal here is to find the side, right? We're not looking for C, we're looking for A. So we need to isolate this A squared. Right now, we can't use a square root to undo this situation since we have this plus 36. So we need to get rid of the plus 36 by subtracting. So we're going to subtract 36 from both sides. And we're left with A squared equals 64. Now to undo the squaring on A, we need to square root on both sides. A equals 8. And that's our answer for our missing side. And again, if we take a look at our triangle, 6, 8, 10 makes a lot of sense. C. So again, step 1 is locating that C, labeling our triangle. So here, 15 is the side that the right angle is looking over at, which means 15 is C. The other two can be A or B. We had X be A before, so we'll have X as B this time. Use our formula, A squared plus B squared equals C squared. In this case, our A squared is 9. Well, 9 squared. B is what we're looking for. C is 15. So we've got 15 squared. 9 squared is 81. B we don't know. And 15 squared, I believe, is 225. Yep. 225. So same thing as before. This time we are looking for B. We need to isolate this B squared on this left side. So we're going to subtract by this 81. Subtract by 81, subtract by 81. 225 minus 81. We're left with 144. So B squared equals 144. And now that we can square root to solve for B. B is 12. Okay, so these are very straightforward Pythagoras examples. Since you're only really doing one step, you're finding a missing side, plugging in the numbers that you have, solving for the missing side. There are more interesting examples, like this one over here, where you kind of have a lot more going on in your triangle, and you actually have more than just one triangle. So now we need to kind of deconstruct this a little and see what we have. So we have a right angle right over here. So the first thing we need to do is always the same, is we need to label the triangle. So if we're looking over from this right angle, we see that this right angle looks over at the side here, 39. And it also looks over at this side up here, X. So we can pull out the two triangles that this right angle is kind of a part of, since those are the only two triangles that we can use the Pythagorean theorem with. We'll see that there is another triangle up here, But that isn't a useful triangle to us since this is not a right angle. The only triangles that are useful are the ones that this right angle is a part of. So since this right angle looks over at this side, that means this and the two sides it's a part of are one of our triangles that we care about. And then the other side that this right angle looks over at is this big side here. So I'll do this one in pink. And again, you want to contain the right angle along with this side. So in order to contain it, we need to box it in like this. So these are the two triangles that we're looking at, is the big pink one that contains the X side and the right angle, and the little yellow triangle that contains the right angle and the 39. So those are the two triangles that we're going to pull out and draw. Okay, so this is one. It's not making the triangle. There we go. So we have one right angle here, one right angle here. This is our pink triangle. What we know here is that we're interested in finding X. So this is our goal. This is 36. And we know that this part is 33, but we don't have the whole length of it. We're just being told that from here to here is 33, and we don't know this section. And then for this triangle, we know that this is 36, we know that this is 39, and we don't know this side. So now we can kind of get a better idea of what it is that we're looking for. Since we need to find this X, that's our goal. In order to find this X, we're going to need both sides of this triangle. Right now we don't have both sides because we only have this kind of portion of it, and this section is missing. We do have enough information to find this missing section because that is the same as this side of the triangle. So this is our first step, is finding the missing side of the yellow triangle. So find missing side of yellow. And then our second step would be find missing side of pink, or find missing hypotenuse of pink. Now that we have our goals, we can get started. So I'm going to work on the yellow one over here. So step one is always label. And since we already used pink, we're going to use a different color. So 1, label. Looking over from our right angle, we know that this 39 is our C. And then our missing sides, our other two sides are A and B. So we've got A and B. Step 2 is always write in our formula, A squared plus B squared equals C squared. And I encourage you to always write the formula and then plug in, just to make sure that you really don't make a mistake there. Just looking at the numbers, sometimes when you do enough of these, everything just starts looking the same, and you might put a number in a wrong spot. So now we have A squared plus now 36 squared. So now I will need my calculator. 1,296 equals 39 squared, which is 1,521. Now, as usual, we subtract this side over here. so that we can get a squared by itself. So we're going to subtract 1,296 from each side. So we're doing 1,521 minus 1,296, and we're left with 225. A squared is equal to 225. We're going to square root that, and we just dealt with the number 225. We know that that answer is 15. So this missing side here is 15. Now we have enough information about our pink triangle. So now we're in the second step. So we found this is 15. So our entire side here is 15 plus 33, 48. No. Oh no. What did I do? Redo. I want to erase the question mark. I'm going to put this as 15, and we'll do this 48. And now we just do our usual thing and find our missing side. So side that the right angle is looking over at, that's x, which means x gets labeled as C. The other two sides get labeled as A and B. Write in the formula, a squared plus b squared equals c squared. Plug in our numbers. A is 48, b is 36, c we don't know. 48 squared, 2,304. 36 squared is 1,296. And now we're going to add these two numbers together. 3,600 is c squared, and now we square root. And our answer is 60. So that's what a multi-step problem would look like. The hardest part of these multi-step problems is really not the Pythagoras section, since Pythagoras, this theorem, this formula, in and of itself is a very straightforward formula. It's really easy to manipulate. There isn't a lot going on. If you know how to, use the squaring button, use the square root button, and add and subtract, then you can do Pythagoras very well. The hard part is when you get questions like this where you really have to deconstruct the problem and identify what it is that you're looking for. So that's the challenging part of this chapter. Other than that, it is a fairly straightforward chapter, and a lot of people have a lot of fun with it. So I hope that you enjoy it. That is all, and I will see you in the next video with more complicated problems. Bye-bye.